In this next video, I'm going to introduce this concept of concentration. So specifically, we're going to talk about the concentration of our solutions. And the first unit of concentration here that we'll talk about, and the main unit that we're going to use is something called molarity. So we can have multiple solutions or two solutions containing the same compound. But they can be very different if these proportions of, say, water as our solvent in an aqueous solution to the solute are different. So we can have varying levels of what we say are concentrations of solutions. And we refer to this unit as the molarity because we measure our concentration in moles of solute. So this would be if we're given 10 grams of something, we divide by the molar mass of whatever that compound is in the unit of grams per mole. We would end up with how many moles we have of that the solute. And then we divide by the total volume of the solution in liters. So we have a unit of moles over liter, and this is sometimes abbreviated MOL over L, and we can abbreviate that even further with a capital M, like so. So this is the unit of molarity. And when we make a solution, when we're mixing a solution, so we're dissolving a solute in a solvent, if we have a known molarity, so we want to have a specific concentration, we would weigh out, find a mass of our compound in grams, and then we would dilute that. We would add that rather to a volumetric flask. So a flask that kind of has this type of shape here, much thinner on the top, and then kind of this round bottom here. So we add our solute in here, and then we raise our volume to a specific line measurement here. So we would add water, dissolve our solute, swirl the flask, and that's what we're mentioning here. So that's how solutions of a known concentration are commonly prepared. Let's take a look at sample exercises 11 and 12 here and see if we can, in number 11, determine the molarity of 100 milliliter sample. And we have 5 moles of phosphoric acid dissolved. So we're going to remember that molarity is going to be a measure of moles of solute divided by liters of solution. So the whole solution, and that's what we're given. So we're told moles, we're told 5.0 moles. And then we're going to divide that by, we have to just convert this to liters by dividing by 1,000 because there's 1,000 milliliters per liter. So after we do that, we would see that 0.100 liters is the same as 100 milliliters. So when we divide this, we're going to see that we have a very concentrated solution. So this would be a 50 molar phosphoric acid solution. Let's take a look at sample exercise 12 now. Now we're asked to solve for how many milliliters. So this is what we're looking for, milliliters. And we're given this concentration of sodium sulfate, so 0.50 molar. And we want to provide a final volume of the salt is the sodium sulfate here. So that's our salt that we're trying to prepare. So we want 0.038 moles. So I'm going to use the same equation where molarity is moles divided by liters. I'm going to plug in what I'm given here. So I'm given a concentration, so 0.50 moles per liter of my Na2SO4, my sodium sulfate, is going to be equal to X amount of moles divided by, sorry, we have our moles as well, right? So we have 0.038 moles, and we need to solve for our volume in liters. So after we plug in everything that we're given, we can see that if we kind of switch these terms here, so I'm going to multiply my equation here by x liters on both sides. That's what I'm going to solve for. And then I'm going to end up taking 0.038 moles, dividing that by my target concentration of 0.05. We know that this is moles per liter. So the moles will cancel, and my unit in my denominator of my denominator here, that liters, that will be my final unit. So I just divide 0.038 by 0.5, and my answer is in liters, so 0.076 liters. After I convert by multiplying now by 1,000, I'm going to see that that's 76 milliliters.